27th eBay Tech Talk. Great that you came here. There are some free drinks, and later we're going to have some more, and food as well. So welcome to the Tech Talk. Today we're going to hear a presentation about load testing at mobile.de. Sergius will talk about Gatling, using Gatling for this at mobile.de. That's really great. Later we're going to have bagels and beer. That's cool, I think. And so one important thing, as always, is we try to get better and better with the Tech Talks. So please give us feedback directly or via email or Twitter. So we're going to have a few links you can follow up on. We have all our jobs at ebaycareers.com. We have a nice tech blog in technology-ebay.de. And please tweet about this presentation, about this event with a hashtag eBayTechTalk. Okay. And I wanna briefly point you to the fact that we're looking for great talents and developers at eBay. If you're interested in that, please follow up with my colleague Svetlana here, site@ebay.com, or talk to us at the reception, let's say, or to me. For instance, we're looking for senior Java developer or for senior Scala, Node.js developers. So there's a lot of interesting stuff going on at mobile.de and eBay in Berlin. Okay, but now let's start with the presentation. Sergius.
Any breathing noises? No. Everybody hear me? Cool. So. Load testing at mobile.de. So this talk is actually about how we were courageous enough to set up a new application in production from which we didn't exactly knew how it behaves under load, because it was a greenfield project developed from scratch. And what I would like to show you in this presentation is like in a two-step process. First of all, show how we managed to put the thing, which was quite unknown to us, into real productive scenarios. Like from a rough strategy point of view. And the second part of this talk should be an overview about the Gatling tool itself that we use to accomplish that. So after this talk, hopefully you will have a basic understanding on how to use the Gatling tool for your own projects and how to generate load and how the semantics of the tools is exposed to you. Short disclaimer, I'm no expert on load testing or Scala, which is the foundation of Gatling, the scripting language of it. I'm just probably, like many of you, just an engineer who wants to get stuff done and put stuff into production. So that's actually my task, and what I liked about the setup, that it allowed me to do these things. That's why I think it's worth talking about. So imagine you have your shiny new application, right? You burned all your VC startup money probably. It's ready for going to production, and it's feature complete. You have done all the functional QA probably, so tested your user stories, and hopefully you fed your system with all the input data that you just could imagine about, with the high variance of input. And the question is, is it ready for prod, right? And obviously, there's still a couple of questions remaining. More concretely, how many instances of this new app do I actually need? How many Amazon instances do I need to spawn? If you have your own data center, how many Java VM instances you have to spawn, how many boxes you put in there. And if your application, as our application does, depends on other services, this question becomes even more complex, because then the question arises, how many additional instances of transient services do you need to install or to spawn in order to get your thing running? How many instances, or do you actually need to scale your Elastic DB, whatever persistent store, to cope with the load you're expecting of your new application? Do you need to adjust or introduce any caches? So these were also the remaining questions for us when we went live, and we wanted to have answers. We didn't want to go just live and see what happens if the system breaks on the load. So the strategy that we applied was pretty easy. We had an existing system, the old public search. Oh, I didn't show it, so let me show it to you. This is how it looks today. You can look for cars in it and buy some of them. And obviously, we already had an existing website who served all of this data. So what we did, we just simply analyzed the existing production load. So we had already some metrics of an expected load numbers. And the other thing we did is we extracted sample data. Essentially, that meant merely just parsing access logs on our web servers and transform them in a way that could be fed into our new system. Then, for the system under test, your new shiny application, we generate load, measure the system behavior. If the system behaves correctly as you expected, well, you quit and have a beer, essentially. Otherwise, configure, adjust, and go back to point 1. That means generate load, and you just do it iteratively until you're satisfied and can go home to your precious family. And that was the process that worked for us. It worked amazingly well. It was amazingly simple. And that's what I want to present. So this is a screenshot of a graphite graph of our old system load. And our simple, maybe naive assumption was, let's have a look at the system load of the past few months, detect the peak load at a given time, at a given point in time, and just use this very peak load as a reference load with an additional margin, of course, and load test our system, our new system, with this very load. Very simple, very easy. This is a screenshot of the sample data that we extracted from the existing system. So essentially, these were just access logs from our old website. And we used these very requests and used those in order to hit against our new application. Very easy. If you don't have an existing system, this obviously is a problem. So you may have to generate, with a good distribution configuration, this sample data. We had the luck that we had an existing system where we were able to extract existing queries. The only thing that we did was we assigned a so-called transaction ID, which essentially is nothing more than a similar semantics to Zipkin or Dapper, which identifies a concrete request such that if any error occurs in the system, we can identify all on the transient services by using this transaction ID. Very simple. So that's our system under test. On the top, you see the evil, fluffy World Wide Web, which generates requests, which are depicted with this sample data just one slide before. And probably many of you have a similar setup. You have load balancers in front, some HTTP servers serving static pages. And then comes our new shiny system, reactive, Java 8, I don't know, the newest fancy technologies. A system as a whole which you want to test. And this was our system under test. Unfortunately, not the whole thing, and that was for practical reasons. We had live traffic going on these web servers, and we didn't want to disturb the traffic. So we would have loved to include the load balancers and the HTTP service in the load test, but we didn't, unfortunately. But it turned out that these guys were not the bottleneck. So more concretely, this system is not a single instance. It's not a single VM. It's a distributed system. So whenever a request comes at this page 7 here, a couple of other systems are being invoked, remote systems. And more concretely, you have an advertising system, which gets back all the metadata for displaying ads. You have some search engine optimization system, which tells us which metadata we should render in the titles and heads and so on and so forth. And then we have the actual search, which in our case is powered by Elasticsearch. So, yeah. And here you can see the result of it. And obviously I have an advertisement blocker, so you don't see the advertising system result. Sorry. So the system under test is not just a single thing, but actually the whole distributed thing in nature. And this is very important because only under these circumstances you can be quite sure that the whole system under test will work in production. So the test setup, again, very easy, very naive. We have made some Gatling scripts. So this tool that we used and that I will hopefully teach you a little bit about is just a scriptable tool. You write Scala code in it. We copied those scripts to some test nodes, which were used as machines which generate load. In our case, there were just 6 machines. And then we used existing tools. In our case, it's been Tmux, but you can also use PDSH, which is a very nice tool from Google. It's a parallel distributed shell, which allows you to invoke multiple commands in parallel on different machines. So I really recommend you these 2 tools. And for Tmux, we just use the synchronized panes feature. So you just hit the keyboard and commands are being executed in parallel on different machines. So very, very naive way of scaling the load tool. And I saw a lot of criticism around Gatling that it misses these scaling features. But honestly, Tmux and PDSH were good enough for the whole setup in our case. These test nodes would generate the requests, which would hit the system under test, which I just depicted before. And then we used the existing monitoring systems in place, in our case Graphite and Grafana, to look for the results. So Gatling comes with its own reports, but obviously it's not so practical because we have 6 testing nodes. So you would have to copy back those 6 reports, mangle them back together somehow. And this was not so practical for us. And we also wanted to see how the system under load behaves concretely when used in our very own monitoring systems, because this is what you will see in production, right? When you will be under load. So we used only those systems to identify bottlenecks, to identify any problems, and so on and so forth. So that was the test setup. So any questions so far? Yeah?
Does it mean that Graphite and Grafana were wired to each of these subcomponents? Like
Yes.
advertising, SEO,
Yes.
all of them, yeah?
Exactly, to all of them. Each of them, it actually, yeah, we had this funny picture in mind. It's like a robot where wires get out of your body. Yeah, exactly. So we have really loads of metrics exposed about every use case, latencies, requests per second, and so forth, error rates, circuit breaker rates, which were fed into Grafana.
And your system understands is this pub-SE, yeah?
Yes, it's PubSE, it's this public search. Okay. And since every request in flight inside the public search invokes advertising, SEO, aggregations, and the Elastic, automatically also those guys are also on the test, obviously, right? So let's see what happened when we first conducted those tests. And this is a screenshot of Graphite from 11 in the morning, and this doesn't look so good, does it? I mean, what you see here is the green line shows the requests per second which were received from those systems, and this is at the PubSE level, at the public search level, so at the level of this application. And the red curve shows the error rate. What you see there is that the error rate was exactly the same as the request rate, which was no good. That essentially means that our system was already in full saturation when being under load tests. So not a good start in the morning, right? So we had to do something. But essentially, the first message was that the metrics exposed the problem to us, which was a good message at least, right? So all the alarms went up, and the application didn't go up. So from this perspective, it was good, but it was not good from an experience perspective, because using this setup, we couldn't go live. So apparently, we set up some countermeasures. The most important one is reintroduced caches. That's what probably most of us are doing. More importantly, we introduced a varnish cache, which already made the situation look a little bit better, but not very, satisfying, because in a system, in a certain point in time, the whole system under test already again went into saturation and introduced errors. So what do you do in this case? Add more search nodes, just scale out, right? I mean, what is the saying for it? Put more iron in the data center, essentially. Yeah, better yet, after introducing even more primary shards to Elasticsearch, we already got a even better curve with successful requests and just little spikes where some requests were being rejected, right? And those error rates went up. The per second rate is the green line. The actual number. Oh, yeah. This test was with around, I think, initially with 1,000 requests per second. Yeah. So yeah. And then the percentage here just only refers to the circuit breaker error rate. Okay. So if you see here, that's like depicted like so. We use circuit breakers for all our transient services, such that if any of those services fails, for instance, if advertising goes down because it's in overload, because it's in saturation, the public search still works. You see the page like so, but without ads, which is good. I mean, you know what I mean. So the same happens for CO, right? If the CO subsystem fails, the circuit breaker kicks in, and you still see the homepage, but you do not have, you just only have a standard title and not so much information. The single point of failure obviously is the search. If the search fails, we don't have ads to display. Bummer. So that's what is depicted with this circuit breaker error rate. Yeah, and then this is, as you see, it's at 5 p.m. It's the exact correct time where we, adjusted all the knobs necessary to have our system in a stable state. So some of our ops magicians, adjusted Elasticsearch thread counts and queue sizes. So I didn't go into detail exactly what we did in order to get the system stable, because this is something that you will have to find out on your own in your very use case. And I think that's not the most important message here. The most important message is, if you don't know how your system behaves on the load, put load on it, measure it. If you're not satisfied, readjust and reiterate until you're in a state like we are here, hopefully, in one day. And if this is the margin that you are aiming for, you're kind of done. And this worked for us very well. We went live with this setup, with this kind of state of the system. And yeah, we have 7:30, so we're like in in the highest peak traffic right now. So it still behaves nicely. Are we there yet? I mean, there's still some to-dos. Currently, in our data centers, we have a static data center partitioning going on. So does anybody know what this is, static partitioning versus dynamic partitioning in data centers? If that is not known to you, is, let's say this setup works stable with 100 nodes of the public search. And what if more requests come in? Then we have to, put more nodes to cope with the load. Currently, in our current setup, static partitioning means is that some ops guy has to come in, install those boxes, put them in the load balancing mode, and hook them in the traffic and flight. That's kind of a static partitioning theme of your data center. Where we want to head to is to have a dynamic theme. So essentially, when you get into a situation like this, so let's say this is like 5 days of operation, and now it's Christmas, right? And you get these error spikes down here. The only thing that the ops people or DevOps people have to do, go into your system and pump up the number of nodes, maybe in a GUI, and then you're stable again. So the theme that we will be using is a Mesos Marathon backends. And if you're interested, it's actually the theme that we implemented. Oh yeah, this is Wojciech. This is our ops colleague. It's essentially an open source project where you can put like a small data center in a box for dynamic partitioning. So, Gatling itself. So why did we choose Gatling? First of all, I had quite some experience with JMeter before, load tested a couple of applications, and to be very honest, who uses JMeter? Okay. Who has meaningful results from JMeter? Okay, so yeah, exactly. And I was in the very exact situation as you were. So whenever I used JMeter, I had those funny graphs which were very, very fun. Yeah? Oh, yeah, I heard about Grindr, sure. Yeah, there are a couple of tools. There's Grindr, there's Vegeta, there's yet another open source system. There's a couple of load testing tools. Gatling worked for us. Find out what works for you and, and use it. Uh-huh. Sure. Okay. So one thing that attracted me to Gatling is that I have very meaningful and reproducible results. And this will be the actual topic of this talk, to teach you JMeter. And we will load test a real small application that I have running here on my laptop. So we will see if Gatling really produces results that we do expect from a simple model that I will explain to you. So Gatling itself is scriptable in a Scala domain-specific language, which is a pro because it's very flexible. But the con is that it's scriptable in Scala. So the pro is a con because it's quite a steep learning curve. So if no one like me had like a big exposure to Scala before, it's like unknown territory. So, and also I found out that the script methods exposed by Gatling cause quite some confusion amongst developers, which I would like to also to clarify in this talk so it becomes more meaningful what those methods mean in Gatling. So, the basic concepts of Gatling, 3 keywords you should know about it is a scenario, an injection, and a simulation. So what is a scenario? And I just copy and paste it here from the Gatling documentation. A scenario represents typical user behavior. In our case, it's very simple. It's a search request towards our website. So we just essentially have one request. More complex systems might have a complete request flow, right? So you might have a login, do something, save something, log out. So you might have rather complex scenarios. And Gatling is quite sophisticated in it. It even allows you to model probabilistic scenarios, like a Markov chain, which is very nice. So you can have some degree of uncertainty in your request flow. The second keyword you should know about is the injection. So this is a declarative load profile which you can inject into a given scenario. So let's say we have a request. This is our scenario. And now we want to simulate 3 concurrent users. This is what the injection is all about. And the simulation is the thing that stitches those 2 topics together, right? So it just combines a scenario with a given injection profile. That's essentially it. And this is our first Hello World example in Gatling. So that's all there it is in order to generate exactly 1 request. And for sure, maybe Grindr is even easier. There are tools which make it easier for you to generate just 1 simple request. But at Gatling, that's all there it needs. So you have your request. It's depicted here like so. And then you declare the scenario. I called it here once, because it executes the request exactly once. Then we inject exactly at once, exactly 1 user. And then we stitch together the scenario and the injection for this simulation. So, does it seem reasonable, readable somehow? Okay. So I have this small application running locally which is called ID Factory. And what it does, it exposes a small REST-based API where you can generate primary keys, nothing fancy. So when you do a post request on it, it generates you a UUID, which is cryptographically signed, nothing really fancy. So we will use this application just because it generates a number every time I hit a post request on it, and we will use a Gatling script to generate load on it. So far, okay? So this is your system on a load. So this is my simulation, which I copy and pasted literally from the slides. Again, here's our request. Here's our scenario, which executes this request once. We inject exactly one user, and then we set up the simulation such that at once one request is being injected with exactly one user at once. One thing to say, if you take this Gatling distribution, they have this directory structure like here, and essentially it's completely self-contained. You just download the Gatling zip from the website, extract it, you just need to have a local JVM installed and you're ready to go. You put your simulations into this user file simulations folder, and then under bin, you can execute the actual Gatling script. I just chose the -m option for mute, such that usually when you start up Gatling, it asks you which simulation to execute, and I just wanted to have it in batch mode, right? So I just say mute to him. So let's see what happens if we execute the script. What I would expect from this script as a result is just, depicted here, like with this simple red dot, just a single request being executed, right? So let's hit it. It's Java, it's Scala, it's a little slowish. Oh, okay. So, and this is the report you get from Gatling. It's generated in the results folder for each simulation that you invoked. I think this is the Unix timestamp, a report for you, which you can open in your web browser. So again, for us, this was not so meaningful because we executed these things on parallel on different machines, but for a local test, it's good enough. Still, those reports are very nice and can give you a feedback if your system actually on a local machine at least works nicely and if your test setup is correct. And yeah, total number of requests we see here is exactly 1. And here we also see the distribution of the response times, which was 4 seconds here. Yeah, and this is exactly what we expected. There's exactly 1 request being executed, as I depicted on the graph. And the response time distribution for 1 request is not that interesting because it's just simply, in this case, 4 milliseconds. And you have many more percentiles which will become more meaningful in further simulations. You also have this details tab, which gives you even more details, reports about the request in flight. Again, this is just 1 request. At least we see that somehow we understood the basic Gatling semantics for executing 1 request. So this is not very interesting, maybe just a hello world example, but at least a good start. So, who of you knows Apache Bench? AB? Yeah. So, exactly. So this is something that comes, I think, with the Apache web server itself. It's a nice tool which actually does a very simple thing. It executes requests towards your web server, and it executes 1 request. When it's done with that request, it executes the next request as fast as it can and goes on and so forth like in an endless loop. So let's simulate that in Gatling. So let's simulate this behavior using a Gatling script. And what you want to do for this is have a different scenario. Instead of executing this request only once, you want to execute it many times. And there's essentially like 2 methods for doing so. Either you can specify a duration, like for 5 seconds in this example, or if you don't like the duration in time units, you can say like repeat only 1,000 times this request and then stop. And then you have basically the same semantics of AB, of Apache Bench. More concretely, there's also a forever method in the Gatling DSL, which lets you forever execute this request until you hit Control C, right? So let's try it out. Let's copy and paste this example, and what should happen then is that, you know, we should have a lot of these dots, right? Given that your application is fast in responses. So for 5 seconds, and this is how our simulation should look like. So let's copy and paste this thing. Okay, so the only thing I changed here, I included this scenario declaration, called it timed scenario SCN, and then I said, okay, using this scenario, inject exactly one user. So what I would expect from the load tool is to have exactly this situation, right? Let's execute it. Again, very slow. Yeah, now we're waiting, not because it's slow, but because we're testing for 5 seconds. So 5 seconds elapsed. That's what it said. And then during these 5 seconds, we executed just a bit over 10,000 requests. So let's have a look. Wow, that looks a little bit better. So we executed during 5 seconds 10,000 requests, which on average amounts to 2,000 requests per second. And yeah, that's exactly the thing that we just depicted before, right? So we have exactly one user going on, one concurrent user going on, which hits our server as fast as it can with requests, right? So intuitively, would you say, is this a good load test? Exactly. So what is this? How would you categorize this kind of test? What is this? This is more like, is this a load test or what is this? What does this thing measure here? Yeah. So I would say this thing measures something like the throughput, right? So imagine a message queue, and you put a message in, message is delivered, you want to put the next message in, you want to put the next message in. So that's actually what this test is all about. It measures how many messages or requests per second can you put in the thing, right? So like serially, one after the other. This is certainly a valid test, but it's not a load test. It's a throughput test, which may be a valid test in your use case, for your application. For learning Gatling, it's certainly meaningful. Maybe it's even meaningful for your message queue, but not so much for our web application. Why? Because we have only one user, maybe some script kiddie, who, you know, fires script against our site as fast as it can. Not so meaningful, but still, you already have some more results about the response time percentiles. So for a throughput scenario, that's certainly okay. And this is also very interesting. You see, like, there is a warm-up going on, right? So at the beginning, there's only 250 requests per second, and at the peak, we're able to cope with 3,000 requests per second. So something like a VM warm-up going on there. Cool. So let's introduce concurrency. And this is what this graph is all about. So let's introduce the same thing as before. Let's execute things 5 seconds long, as fast as we can, serially one after the other, but not with one user, but with 3 users at once. So like the sum of all of those requests should look like this. And if you use the same graphing technique as before, this should look like this. So we have 3 users concurrently banging our system under test, and each of those users perform requests one after the other serially as fast as it can. So intuitively, the scenario is exactly the same, right? Because each user does the same thing, but not with one user, but with 3 users at once. So yeah, we use the same scenario, but instead of invoking this scenario with 1 user, we do it with 3 users. So far, so good? Simple. So let's see. Again, we'll have to wait 5 seconds again. wow, we have a much higher throughput now, right? We have 21,000 requests in total invoked with 4,000 requests per second. And now you see, that's interesting, right? We have active users along this, now we have 3 instead of 1, which is exactly what we wanted to model, right? Again, the response time distribution. And is this a load test? Not so much, right? So it's, again, a throughput tests, but like with concurrency, like with 3 users. It's a little bit like, I don't know, if you have like a node application, right, you may have like as many instances as you have cores, and this may still be a valid test for throughput on a multi-core machine for a messaging queue. I don't know. So you can do more interesting things with Gatling, and we are kind of shifting gears now a little bit with the Gatling DSL. So let's say you want to have the same thing as here, but skewed in time. So you don't want to hit the server at once with 3 users, but you want to have something like a ramp up. So first you want to have 1 user, and then after some configurable amount of time, the second user, and then again after some configurable amount of time, a third user. And that's exactly what you can do with this constant users per second for a given duration. So what does this mean? Let's think about this. So it means we constantly inject, in this case, 1 user during a period of 3 seconds. Such that in the first second there is 1 user, in the second second there is a second user, and in the third second there is a third user. So given this scenario, how would you expect does the graph look like in Gatling? So in the first second, how many concurrent users do you have? 1. In the second? In the third? In the fourth? Still 3, 3, 2, 1. So it should look like this, right? So let's see if the model holds that we developed in theory. Let's see. We take this 5 seconds scenario and constantly inject 1 user per second during 3 seconds. So we should expect this step thing going on. Let's see if this holds. So in the academic world, one would say we are conducting experiments, right? Yeah, exactly. So in the first second we have 1 user, then we have 2, 3, 3, 3, 3, and then it goes down. Cool. And this is something I really like about Gatling. Whenever I try to think about those scenarios and those injections, I write those helper scripty thingies and check if the model holds just by looking at the graphs, and then I kind of assume that my thought was correct. So, and this is something I encourage you to do when you are playing with Gatling, to do these very same experiments. And as you see, it's a very clean graph, something I have never seen in JMeter. Yeah, so this is the graph that I came up with in theory, how it should look like, right? And then you saw the thing in Gatling. So this constant users per second is nice, but you need to do the math in your head, right? So you know that after 3 seconds, you would like to have, I don't know, 10 users. So you have to think, okay, so I want to inject, I don't know, 10 users per second in a duration for 3 seconds, such that I have after 3 seconds 30 users, right? So you have to do the math in your head. In order not to do the math in your head, you can use a Gatling function, which will do exactly the same thing depicted by this constant users per second injection. It just says ramp 3 users over 3 seconds. Right? And then we should see in the Gatling report exactly the same thing. So okay, so you see these guys are very similar. Whoops. This one in the first line, constant users per second, says inject 1 user per second during 3 seconds, and here in the line below you declare like the given or the wished end result, which is a little bit different semantics. So let's see if it holds. We'll have to wait for 5 seconds. As expected, the very same thing, right? Just expressed a little bit differently. Cool. And you can go even more crazy with this. So what you saw with this, so we're like in the third gear now in the Gatling DSL. What you could do with this constant users per second injection, you can also do with the ramp up. So you could say ramp up in the first second 1 user, then 2 users in the second, and 3 users in the third second. Right? So, and this is already getting a little bit more interesting for us when it comes to real-world load testing, because this is how your profile looks like when it becomes Christmas. Right? In the morning, there's just a few people, and then in the Christmas Eve, there's like millions of people banging a website. Well, maybe not on Christmas, but maybe, I don't know, on another interesting day. So this ramp users per second already gets interesting. So if we combine this with this time scenario we have before, we have this exponential thing going on here. So in the first second we have 1 user, in the second we already have 3, in the third second we already have 6 users, right? And then it goes down. So constant users per second, ramp injection, and ramp users per second. Is this a little bit becoming more clear now? Cool. Do you want me to test it? You believe me? Okay. So there is another injection type in Gatling which caused quite a lot of confusion amongst our developers. What it actually means, it's this heaviside users injection. And this heaviside is being inspired by a step function. If you remember, like this mathematical thing. So you have a step function which is kind of smoothed out. And sometimes in the real world you have exactly this function going on in your production systems. So in the beginning there's just a few users on your system, then they pace, then the growth is very high, and then once in the peak load situation it kind of flattens out a little bit. So did you see something like this in your graphs? Probably yes, right? And this is what this heaviside users thing expresses. It injects 200 users in a given period, in this case 10 seconds, such that the cumulative distribution function looks exactly like the stepping function here. So the problem I had with this, how does this look in the reports? Because it doesn't look like this. So think about this, and I had to think about this for a couple of moments. What does this mean like in concurrent users? Where do you expect like the peak load? It's where the slope is at its maximum, right? So it should look something like this, right? So when the slope is at its maximum, we have the biggest amount of concurrent users going on, and then when the load goes down again, it smooths out. So it should look, and I did this in LibreOffice, so it should look like this, right? And this is a typical peak, right? So you have like a slow growth, then you have peak load, and then it goes gradually down. So let's see if this works. Hopefully it does. And let's take the once scenario, because I don't want these 5-second requests going on. It will take 10 seconds now. And imagine a couple of engineers sitting in front of the Grafana matrix looking for errors or saturation modes, something like that, because our tests were like a half an hour, 1 hour. So, awesome, nice. So it's exactly this thing that I calculated in LibreOffice. 42 thingies going on here, so it's exactly, the numbers are even correct, right? Again, this is something I like about Gatling, very reproducible, right? So it's flattened, it's like, this graph is just squeezed, right? But essentially it's the same graph, okay? So by using this Heaviside function, you can simulate these kind of peaks in your application. Honestly, I didn't find this function to be very much of usefulness for me, because those peaks are not kind of in a certain point of time, but they stretch, right? So that we might come at a peak point which lasts like for half an hour, and then goes up again and goes down again and goes up again and then, you know, falls down. So it's not like simple like this. Maybe the Gatling authors can provide more parameters in the Heaviside function to give us a little bit more possibilities. But still, I think it's worth talking about, because this was one of the most mysterious functions in Gatling when we were playing around with the tool itself. So there's quite some more methods. I won't show you all of them, but hopefully you have kind of an overview what possibilities you have for injection methods and for scenario methods. I showed you essentially 3 scenario methods: this once injection, this request over time, and this amount, but there's much more. And also you have a little bit more of injection methods, but there's not much more, so there's not much more to learn. So how did we actually model the Gatling script? Because as of now we only had like the basics of Gatling. Now let's switch to the final gear, how we did actually model the thing. So how does load actually look like in production? It's not like a throughput thing that's going on. Users are hitting your website more like this, right? So in the morning, we just maybe have 1 user going on, and then we have 2 users concurrently going on, then we have 3 users concurrently going on. And in our case, when we conducted those tests, we tested here like these 1,000 of concurrent points to the above. And this is like a little bit more of a realistic view on how your load looks like. So how do we model this thing? And this is something, again, that I like about Gatling, is that it lets you stitch together and combine different injection profiles into one simulation. Because you can divide this scenario, this simulation scenario, into 2 steps. First, the ramp-up phase, which is depicted by these first 3 seconds, right? And then this constant rectangular block from second 4 up until second 8. And how do you expose the semantics in Gatling? Well, in order to simulate, you want to ramp 1 user per second from 1 to 3 during a period of 3 seconds, right? Can you follow that? Cool. And that's exactly what we expose here. You ramp, our ramping phase says ramp 1 user per second from 1 to 3 in a period of 3 seconds. Once we reach that point, we want to be on a stable high load scenario, and then we want to inject constantly exactly this peak users per second during a given amount of time. So in this case, we want to inject 3 users per second during 5 seconds in this example here. And for us, this is the most realistic simulation that we can have from our website. And this is, in our opinion, much more valuable than just a pure throughput when it comes to websites. So let's see if this holds. So yeah. We first want to have the ramping. And after we have the ramping, we want to have the constant, right? Okay, and you can just comma separate them, those injection profiles, and you can have that's actually a variadic argument list. So you can stitch much more of those injection profiles in there. So let's see how it looks like. Yeah, maybe not so perfect as in the assumption, but at least you have this ramp phase, 1 user per second, 2, 3, then for 1, 2, 1 second, 2, 3, and then this is the ramp down phase. The thing is shutting down, still one left over, but this should be ideally a straight line, but essentially it resembles the thing that we wanted to model. Okay? So yeah, this is how it should look like. The very end was a little backed off there, but yeah. So this is our script that we used to load test the whole public search. And I will go through some details in there. So instead of hitting only one endpoint, as we did in our case here on localhost, we just gave it a list of hosts. Remember, we have a static partitioning theme in our data center, so we have a static amount of nodes serving our application. And the nice thing is that Gatling will just simply round robin for you all those nodes for each request. And then, yeah, we just declare a few headers. And then what Gatling has is this nice thing which they call feeder. So you give it a file. In this case, it's our sample data set, which I just showed you before. It's this tabular separated file. Picks any request from it at random and executes, in this case, a GET request. And what is nice, you can take those variables here, which take the values which I showed you from the sample set, it's the query, and the TX ID, and puts it in the header. Okay, so there's some templating going on. And this is one request, and this is just simply the search request, chosen randomly from this sample data set. So what do we do? Our scenario looks actually very simple. We don't have a login, logout, or something. Essentially, our scenario is just executing the search and you're done, right? So our scenario is very simple. We just execute the search request. And here you see exactly the thing that we just did before. We have a ramp phase. Yeah, in this case, just for example, to 103 concurrent users during 1 minute. And then during 30 seconds, we constantly inject 123 users during 30 seconds. And the numbers were a little bit different in our case, but essentially that's the whole script, which was used to produce those funny graphite results that you saw in the very first slides. One additional note on this randomized thing here, that's actually very nice. You can add an additional parameter called randomized in Gatling for this constant users per second injection type. Why is it interesting? Let's have a look back here. So when you just use this constant users per second, like so, Gatling will be very precise and at every second exactly inject 3 users. But that's not how real life works, right? I mean, in the real life, you have those 3 users kind of, this one starts here, this one starts a little bit here, and this one may start here. So they are kind of uniformly distributed inside this very second. And if you want to exhibit this very behavior, you give it this random parameter. So just to introduce a little bit more randomness, which is nice. We copied the script on the 6 testing machines, fired the Gatling scripts, and produced those graphite results. That's actually all we needed to load test our application. So, learnings. Actually, this is my learnings that I would like to communicate to you. Measure your system on the load, adjust it, measure, refactor until it looks good to you. Don't try to be smart enough in forehand and try to predict something which you don't know, especially in distributed systems. There's so many factors. especially if you have something like microservices going on, where you have a lot of remote calls. You should test the whole thing in its distributed setup and put load on it in order to have a valuable information. That's essentially it. That's all I wanted to show you. It's 8 o'clock. Thanks a lot.